Hello class, so in this video we're going to be talking about properties of logarithms and also just demystifying what a logarithm even is. So these are the 5 things we're going to go through. Okay, let's get started then. So there's a thing called exponential form and there's a thing called logarithmic form. This is literally a definition, so there's really no derivation for it, but there can be explanation for it. So let's look at the explanation for it then. So let's kind of color code this. Let's make the logarithms blue and the base of the exponent yellow. So if we look at it like this, then we see that essentially what's happening with the exponent is we have a base, that thing's multiplied by itself x times. With the logarithm, what we say is log base a of y equals x. So that means if we're counting things in an a way, so by multiplication of a, going each step of the way, in order to get to y, so in order to get here, that's the destination, we need to go this number of steps. So if we look at it with the same examples that we were looking at last time, with the exponents, if you saw that, multiplying by 3. So multiply by 3, multiply by 3. And we're starting with 1, right? So if we start from 1 to 3 to 9 to 27 to 81. So if we're starting with 1 and we wanted to get to 81, how many steps do we need? The number of steps of multiplication by 3 is 4 of them. That's why you can say then that log base 3 of 81 is 4. Because this is also just saying 3 to the 4th is 81. So think about this. If you need to pause the video to process this, please do that. This is a very important idea to understand before moving on with anything logarithm related. Otherwise, you will be very confused. Okay, so let's look at this and try to prove this somehow. So again, let's just color code because colors help us differentiate things. So let's just say let c equal log base a of x, and let d equal log base a of y. So first thing to ask is, well, what can we even do with this at all? Because right now all we have is 2 logarithm things and some random variable that we made up because of reasons. Well, we can always write it in exponential form. So let's try that. So remember, c is the exponent, a is the base. And then x is your destination with exponentiation. So then we can write a to the c equals x and a to the d equals y. Okay, so we see that in our target at the end, we want to somehow multiply x and y. Well, notice we have x, we have y. How about let's just multiply those things together and see what we get. So x times y, what does that give us? That gives us a to the c power times a to the d power. Well, if we use our properties of exponents, which we probably know very well by now, then this is a to the c plus d power, right? Well, what can we do with this? Let's write that in exponential logarithm form now. That's log base a of, what's the destination of this? This equals that equals what? C plus D. Well, what are C and D? C is log base A of X, and D is log base A of Y. So, what that tells us then is log base A of XY is equal to log base A of X plus log base A of Y. So we've actually just proven this statement right there using that trick. So, yeah, let that sink in a little bit. Try to see the logic there. Essentially, all we did was put things into exponential form, apply some properties of exponents, and then put them into logarithmic form. Then manipulated things and noticed, hey, that actually works out to be what we want it to be. Alright, next one. We can actually apply the exact same thing here, so I'm going to leave this kind of as an exercise for you to do to see if you understand how that works. And I will leave the solution worked out as a picture or something in the description below. So, do by yourself. Just a mental exercise. Then check in description. Alright. So now let's look at this. This is an interesting one. So basically, the exponent is able to go down. Question is why. So let's just do stuff. So we could turn this into x times x to the n minus 1, right? So then by property 2 up there, what we get is that the logarithm can split into 2. Alright, cool. So how about this then? Let's do the exact same thing. X times x to the n minus 2 this time. And then the logarithm can, again, split into 2. And then this can go on basically forever until, well, not forever, but until the n and the exponent of that thing just runs out. So in other words, what's happening, you can also look at it this way. That you have x times x times x. How many times? That's n times. So you're essentially breaking all of these into multiplication or addition. So it's just log base A of x plus log base A of x. And that just continues going on n times. That's really what this is showing us. We're seeing that it's going to slowly do that. So this is n times. In other words, we have this quantity n times. So in other words, n times log base A of x. So that's why that works that way. Alright, so now for this one, let's actually go back up to that original number line thing that we had and kind of logic through it. Or I'm going to redraw it here so that we don't have to scroll back up there. So what this is telling us is a to the power of 1 equals a. In other words, if you wanted to, you can think of it as how many steps does it take to go from 1 to a. It takes 1 step. That's really all this is saying. So if you understand the way that logarithms work, then it makes perfect sense that log base something of something is just 1, because it just takes 1 step to go from 1 to whatever the base is. Alright, so this is the reason behind all those logarithmic things and laws and stuff that you were supposed to memorize. And yeah, so this is where they come from. Hopefully this was helpful, and I'll see you guys in the next video.